Hi, so today I'm going to be talking about writing ionic versus covalent compounds. Firstly, we're going to do some quick background research on cations and anions. A cation is a positively charged ion, while an anion is a negatively charged ion. Here we have sodium, and if we look at our periodic table, we can see that it's in the first column. And if we know our charge rules, we know it has a +1 charge, therefore making it a positively charged ion and a cation. If we look at sulfur on the periodic table, we see that it's in the 16th group, therefore giving it a -2 charge, making it an anion with a negatively charged ion. An ion is just a charged element. Next, we're going to look at an ionic compound. An ionic compound is a transfer of electrons between a metal and a nonmetal. This creates a lattice of alternating ions shown below, and ionic compounds conduct electricity when dissolved or melted, and they have a high melting/boiling point. They're also usually solid at room temperature. Next, with covalent compounds, they're a nonmetal, in a nonmetal, and it forms from a sharing of electrons. These form singular molecules such as this water molecule shown to the right, and they're not conductors unless they're an acid and have a low melting/boiling point. Also, they're usually liquid or gas at room temperature. So these are 5 examples of ionic versus covalent compounds, and we're going to figure out which they are. So we're just going to look at 2 examples from this. The rest you can do on your own. But here we have carbon monoxide. And if we look at a periodic table, we can see that carbon and oxygen are both nonmetals, therefore making it a cation. Here we have NaCl, or sodium chloride. If we look at our periodic table again, we can see that sodium is a metal, and therefore we don't have to look at what chlorine is, and we just know that this is a ionic compound. And there's no need to, and we're not going to do the rest of these on this video, but you can do them on your own. Now we're going to learn how to name ionic compounds. And ionic compounds are named in kind of a different way because you have to look at if it's a D block or S or P block element or cation. And if it's a D block cation, we don't change it, but we write the charge in Roman numerals and parentheses next to the element. If it's from the S or P block, we don't change it at all. If it's an anion, when you have an anion, you change the ending of it to an "ide." So here we're going to do the first 2, and we firstly have iron, so we're going to write iron. And since we know iron is in the D block, if you want, we can look here and we can see that iron here, number 26, is in fact in the D block. And we can see that we have 3 bromines, and if we know our charge skills, we know that bromine will have a charge of -1, therefore giving a total, all these bromines, a charge of -3, giving iron a charge of +3, so we'd write 3 in parentheses. Then since bromine is our anion, we would change it to bromide. And next we're going to be looking at magnesium, or we're going to look at MgBr, magnesium in a bromine. And firstly, again, we're going to write magnesium first because it's just the first element, but we're not going to write the charge in a parentheses because magnesium is in fact a S block element, so we don't need to write the charge. Then we're going to write bromide once again with no changes to it. Remember to write your "ide" at the end of all your anions or your second elements to keep the ionic compound rules. Next, we're going to look at covalent compound naming. So when we name covalent compounds, we use prefixes such as mono, di, tri, tetra, penta, hexa, hepta, octa, nona, and deca. And these you can all memorize, and they're easily memorized from knowing shapes and things like that. And here are the rules for naming them. We use a prefix for the first element unless there's only one of them. Then we wouldn't use mono, and we would use no prefix. We add a prefix to the second element and change the second element ending to an "ide when we drop the last letter of the prefix if the second element is oxygen, just so you don't have a double vowel. Here are some examples for naming covalent compounds, and we are just going to do the first two. So here we see we have one sulfur, and you'd think we would write monosulfur, but since it's just one, we just write sulfur. And next we see that we have fluorine, but we have 6 fluorines. And knowing our naming rules, we know that 6 turns into hexa. And fluorine would then be changed to fluoride, because it's the second element. And then next we're going to look at N2O5. And here we can see that both of these elements, both these ions, have multiple ions with them. So since it's 2 here, we can write di as our prefix and just write nitrogen normally. And we can see here that oxygen has 5, and we know our prefix for oxygen is penta, but if you write pentaoxide, remembering to change the ending to I, we see that we have a double vowel here, which is something we do not want. And to change this, all we would do is remove the A, making it pentoxide. And we obviously wouldn't have the space when writing it normally, but that's just, you would just put those together when writing it, just to make it sound better. And the next 3 you can do on your own, and we can use this periodic table just to make sure that the compound is in fact covalent or ionic. And yeah, that's it for this video, and I hope you now know how to name ionic versus covalent compounds.